my Catines, a very warm welcome to your today's chemistry session, and this class is going to be super important because we would be revising the entire chapter periodic classification of elements just in the one go. So make sure that you attend the entire session. If in case you haven't understood any of the portion from the chapter, don't worry, because I am here. Okay, so do not fear when Shilpi Mam is here. If in case you're new on the channel, then you have to subscribe to it, and I guess you know my name now. It's okay if even if you forget that, I'm still gonna teach you. So I am your chemistry master teacher Shilpi Kaushik here at Vedantu. So let's get started, and this is your Shilpi Mam's coupon code. If in case you want to be a member of the pro subscription, a student that is getting unlimited live classes at Vedantu with unlimited doubt solving during the live sessions, and not just that, you do get free crash courses, test series and mock papers and lots of other stuff that makes you ready for the competition, and that is a coupon code that can help you to get 10% discount always. FKA Pro, link you do get in the description box of the video if you want to join us. Okay, so let's get started without wasting any time. The question number one, ma'am, why do we need to study this chapter? What makes it so important that CBSE asks every time 5 to 6 marks ka, the weightage is given to the chapter. It's a big thing. 5 to 6 marks you are straight away getting from one chapter. So there would be something about the periodic classification of elements. So let's understand classification in our daily life. That is simply sorting. Just say you go to a shopping mall, then you feel it's so easy to do shopping over there because things are sorted in a way. All the similar things are kept together. Like if you want to go to a kids store, then there is a separate kids section. If you want to buy something like shoes, aapko chahiye, there is a separate section for that, and so on. On the other hand, if you go to an open market, then it becomes so difficult to figure out stuff. What do you want to purchase? It's damn difficult. So we have to have the classification of things, the sorting of things. That's human nature. घर पे भी you are always keeping your physics book separately, chemistry separate, math separate, social studies separate. Why? Because that makes us convenient to find the things, to study the things. It's easier. Similarly, you know that we are having 118 elements that are discovered till this date. So if I ask you that you have to study each and every element individually, would you able to study it? Of course you can, but it's gonna take you a lot of time. 118 element, each element is having different properties. You gotta study their physical nature, chemical nature, how do they react, what kind of properties, what kind of compounds they are gonna make. So what do we need? We need some sort of classification over here, that if in certain elements, if we observe there are some common nature, there are some common physical or chemical properties, so better we group them together and keep them at one place. So it's like, let's say I have grouped 20 elements together. If I'm studying one element, that's equivalent to studying all the elements. So elements with the similar properties we are intending to keep together so that the classification, the study of those elements becomes easier. That was the major requirement of classification of elements, and different scientists had given the different contributions at different times. Like the first one, about the father of modern chemistry, Antoine Lavoisier. Antoine Lavoisier, what did he say? He said that there are so many elements, but there is certain similarity, and he classified those elements as metals and non-metals. So you know that metals and non-metals have very opposite chemical as well as physical nature. You have done this already in chapter number 3. So metals, if you talk about physical nature, metals are malleable, they are ductile, they are hard, they have high melting and boiling points. On the other hand, non-metals will behave opposite. Exceptions are always there in chemistry, so not talking about that, but still that majority of the elements, almost 80% elements that are known to us, are metals. So do you think it is a good criteria of classifying? Yeah, but this is enough. This is good, of course. Is this enough? Can we stop here where majority of elements are metals? After some time, metalloids were also discovered, some elements which are having properties that resembles metals and non-metals both. Just you have some example, boron is there, silicon is there used in solar panels, germanium is there, arsenic is there, some of the metalloid. But this classification needs to be intensified more. So then came the contribution of different scientists. So we would be studying with the first thing, the early attempts of classification. So the first attempt was being done by Dobereiner. Okay, Dobereiner's triads. The name is itself telling you. Triad means group of three elements. What is this telling you? Group of three elements. So what Dobereiner did? Dobereiner made group of three elements. That you can see here. Lithium, sodium, potassium was one group that was made by him. Calcium, strontium, barium, fluorine, bromine, iodine. Now on what basis he has made the group? Dobereiner said that if you arrange the elements in increasing order of atomic masses, what I am saying, he asked us to arrange the elements in increasing order of atomic masses. Okay, increasing order of atomic masses. Then he said that you see a very beautiful variation. And what is that? Let's say this is the first triad I have made, lithium, sodium, potassium. Lithium is the first element, sodium second, and potassium third. Atomic mass देखो, lithium has atomic mass 6.9, sodium 23 and potassium 39. That means increasing order of atomic mass is being followed. Then he said that if you take the average of atomic mass of first and third element, what I'm saying, you have to take average of atomic mass of first and the third element of the triad, that comes out to be roughly equal to atomic mass of second element. Wow. Is it happening? Watch it out. 6.939, you're going to take the average of it. That's coming out to be around 23. Roughly equal to atomic mass of second element, that is sodium. Yes, that was a pretty classification. And not just this, he said that now all these elements which are falling in a triad, they would be having similar chemical properties. He said that they have similar chemical properties. That was true. Lithium, sodium, potassium, the kind of oxides they make, hydrides they make, that is going to be same. The kind of valency that is exhibited by them, that is all one. They all are metals. Okay, so there were a lot of properties that were resembling. Similarly, the second triad was calcium, strontium, barium. Here also you take the average of atomic mass of first and third element, roughly equal to atomic mass of the second element. So exam mein sometimes such questions are asked that if first and third element of Dobereiner triad is chlorine and iodine, what is the second element? Bromine. And they all would be having the similar chemical properties, the elements which are falling in the same triad. So that was a very chotu sa simple sa classification, although there were some limitations here. The limitations were that all the elements could not be classified. Like all the elements that were existing at that time, there were less elements, around almost 22-23 elements the, so they all were not obeying this Dobereiner triad. Okay, so you can say that it was not applicable to all elements that were discovered at that time. So you can see he has given 3 successful triads. Not just that, there were some elements which were following this atomic mass wali thing, the average wala thing. Just if you take carbon, nitrogen and oxygen, atomic mass of carbon is 12, nitrogen is 14, oxygen is 16. So if you take the average of atomic mass of carbon and oxygen, that comes out to be equal to atomic mass of nitrogen. But they don't have similar properties. Carbon, nitrogen, oxygen have different chemical properties. So there were some elements that were following this criteria, but they had different properties. There were some elements which had similar properties, but this mass wala funda was not justified. So this classification failed after some time. Newland came into the picture. Newland was like, it's okay. I am fond of music, and Newlands ने जो law दिया, that is the, like you can see, law of octaves. So octaves is reminding you of the number 8. He had something to do with number 8, and because he was fond of music, so Newland said that, have you ever played some music, Indian classical music की बात कर लेते हैं. We are playing sa, re, ga, ma, pa, dha, ni. What is the 8th note? Sa again. So like he didn't know about Indian notes, I guess. So it's just that we are explaining it in a way. So in the musical system, you see the 8th note is resembling the first note. You start with sa, you are getting back at sa. Just like that, he asked us to arrange the elements in increasing order of the atomic masses. So similarity that you see here, Dobereiner also said the same thing, that we would be arranging them on the basis of increasing atomic masses. The same is said by him. And then he said that on doing so, like hydrogen, lithium, beryllium, that is all in increasing atomic mass, then every 8th element is resembling the first element. What did he say? That if you arrange the elements in increasing order of atomic masses, then what do you observe? Every 8th element is found to have properties similar to the first element. Okay, so that means sodium resembling lithium, magnesium resembling beryllium, aluminium resembling boron, silicon resembling carbon, phosphorus resembling nitrogen, sulfur resembling oxygen, and so on. But was it so easy? Nope. Because this classification was only limited till calcium. Only 18, like roughly 18-20 elements were found to obey the Newlands Law of Octaves. It was not applicable to higher atomic mass wale elements. That means yttrium is not going to resemble chromium. Indium is not going to resemble titanium. Arsenic will not be resembling manganese. Selenium will not be resembling iron. Yes, so all these elements. So there was a drawback. It was applicable only up to calcium. Okay, it was not applicable to higher atomic masses wale elements. They were not obeying it. And other limitations, you see cobalt and nickel. How can you keep two elements at the same slot? Okay, they might be having similar property. They don't have same properties. How can you keep them together? The masses would be different. Not just that, not just he kept the elements in the same slot, but he also kept dissimilar elements together. Cobalt and nickel do not have any resemblance with chlorine. They are typical metals. Chlorine is a non-metal. Cobalt, nickel are not resembling fluorine, hydrogen. Okay, bromine is not resembling them. No. And iron, cobalt and nickel were having some resemblance. They were kept far apart. They should be kept in the same group, isn't it? So what do you see here? Similar elements have been kept far apart. Dissimilar elements have been made together. So it's like, that class teacher. There are some class teachers who make you sit in a way that, best friends are always instructed to sit apart from each other. So Newland is kind of giving me the same feeling. So there were a lot of limitations that needed to be fixed upon. So after this came the Mendeleev into the picture. So Mendeleev's periodic table. Now Mendeleev is regarded as god of periodic table. So this man has literally given so much contribution in the classification that we should actually just pay so much respect to him, because he devoted entire his life in the classification. So he examined the relationship between the atomic masses again. Yeah, he also arranged the elements in increasing order of atomic masses, just like the other scientists. And the good part is that he talked about their physical as well as chemical properties. Not just chemical, he also paid attention to physical properties. He was like, let's give a classification jahan par, both the things are sorted. Now the fundamental property that was taken by him was what? Atomic masses. Okay, acceptable. Now what did he do? He arranged all the elements in increasing order of atomic masses. I'll show you his table. यहाँ पर देखो, सो दिस इज इंक्रीजिंग ऑर्डर ऑफ एटॉमिक मास. हाइड्रोजन के बाद लिथियम, बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन. यू कैन हैव अ लुक एट देयर मासेस. इंक्रीजिंग ऑर्डर है. देन ही मेड देम रिएक्ट विद ऑक्सीजन एंड हाइड्रोजन. मतलब ही टुक एन एलिमेंट, लेट्स से एलिमेंट इज E. He did its reaction with oxygen. Similarly, he made the element react with hydrogen, and then he studied their oxides and hydrides. The formula of oxides and hydrides were studied by him. And उसके बाद उन्होंने क्या किया? Elements which were making the same kind of formula of oxides and hydrides, they were kept together in the same group. What did I say? I repeat myself. I am telling you that Mendeleev arranged the elements in increasing order of atomic masses. ठीक है, ऐसा किया उन्होंने. And then he took every metal and made it react with oxygen and hydrogen. Then on doing so, he is getting oxides and hydrides of metals and the non-metals. So elements which were giving him the similar formula of hydrides and oxides, they were kept together in the same group. And he said that they are having similar properties. Now what could be the reason? Think about it. The formula of hydrides and oxides formed by element were treated as one of the basic properties of an element for its classification. Why only oxygen and hydrogen? Because they are quite reactive. Oxygen and hydrogen can almost react with every element. Quite reactive, okay? And then he gave a law also. Mendeleev was like, I'm gonna give my law. The properties of elements are periodic function of their atomic masses. Periodic function क्या होता है? A function that repeats itself, that is repetitive. Okay, it's gonna repeat itself. So he said that you take the elements, arrange them in increasing order of atomic masses, and then you see that elements with the similar properties are gonna repeat themselves. Yes. So sometimes this question can be asked for 1 mark. You have to be ready for it. Okay, the kind of explanation that you have to give. This statement should be crystal clear. The properties of elements are periodic function of their atomic masses. Again, I repeat, if I arrange the elements in increasing order of atomic masses, elements with similar properties are repeating themselves. How they are repeating? Dekho, he has arranged them in the increasing atomic masses. Then all the elements which are found in the same group. Group is a vertical column. Okay, this vertical column, this is known as groups. So in Mendeleev periodic table, you will have 1, 2, 3, 4, 5, 6, 7 and 8 groups. Okay, out of these 8 groups, group number 1 to 7, they were also subdivided into the subgroup A and B. ठीक है, यहाँ पर अगर आप देखो हाइड्रोजन, लिथियम, सोडियम, पोटेशियम, दे आर इन द सब ग्रुप A. There is copper, then you have silver, gold, they are in the subgroup B. Okay, so groups were divided into subgroups except for the 8th group. यहाँ पर elements with the same physical properties were kept. Okay, so you do get what? Vertical columns, they are known as groups. Very cute girl. Vertical columns are groups. HRP. Horizontal rows are periods. Harsh Priyam sir, you can remember. Haryana, Rajasthan, Punjab, Hari Prasad, whatever you like. Horizontal rows are known as periods. And in Mendeleev's periodic table, there are 8 groups. Vertical columns कितने हैं? 8 हैं. One extra group was added after some time, that was 0 group for noble gases, but noble gases were not discovered till now, so he didn't talk about it. बाद में he added it separately. And there are 7 horizontal rows known as periods. Okay, so if you pay attention here, I was saying that like hydrogen, lithium, sodium, potassium, the elements which are falling in the same vertical column, they are having similar properties. The formula of oxides and hydrides is same. Lithium oxide Li2O, lithium hydride LiH, sodium oxide Na2O, sodium hydride NaH. Okay, rubidium oxide Rb2O, rubidium hydride RbH. So if E is the element, then the formula of hydrides in group 1 is EH and oxides is E2O. So elements with the same formula of hydrides and oxides were kept in the same group and they were having the similar properties. What could be the reason? Reason क्या हो सकता है? Valency. If they have same hydrides and oxides, probably they would be having similar valencies. They all are having a valency of 1. है ना, there would be some resemblance. So that is how he talked about it. And one more thing that you can see, there are some space in the table, lots of spaces. यहाँ पर कुछ element का gap है, यहाँ पर gaps are being left here also. So these gaps are left for the undiscovered element. That was a plus point. Mendeleev left some gaps in his periodic table. Now, instead of looking upon these gaps as defect, these were not the drawbacks. Mendeleev intentionally left the space. Mendeleev was like, okay, I know that there he just figured out at the time of Newlands there were 56 elements. At the time of Mendeleev 63 elements were known to us. So he knew that new elements are being discovered and they would be discovered in future. So Mendeleev said that I am leaving space in my periodic table for some elements, and these elements you will be discovering in future. And you will keep those elements right here at the position that I'm leaving vacant. So is it less than astrology? You tell me. Mendeleev scientist थे कि astrologer थे. He exactly predicted the existence of some elements, and not just that, he also talked about their properties. Yes, not just he left the gaps in the table, he also predicted the property of those elements. And guess what? When these elements were actually discovered, then properties that were predicted by Mendeleev were resembling to a very, very, very close level. That was like people were surprised. How is it even possible? Like scandium that you know today was given a name Eka boron by Mendeleev. Eka is a Sanskrit word, so that means first. First comes boron, then the undiscovered element scandium. जैसे यहाँ पर we are having boron, यहाँ पर after one element, यहाँ पर he kept Eka boron. Like aluminium is coming here, after one element, here will come Eka aluminium. Silicon is coming here, after one element will come Eka silicon. Okay, so what did he say? He said that I'm naming this element as Eka boron. These are the properties. This is the melting point. This would be the oxide. This would be the chloride. This would be the density. And you will discover it in future with this resemblance. And the same thing happened. The element that you call as scandium today is nothing but Eka boron predicted by Mendeleev along with the properties. Similarly, Eka aluminium was a name given by him, and which is now known as gallium. Eka silicon is now known as germanium. So you have to learn these three names. You can use some slight trick, whatever suits you. BSc से याद रख लो, Bachelor of Science. Eka boron is known as scandium. Eka silicon is known as germanium. याद रख लो, both of them are metalloids. Boron is also metalloid, but yeah, they are just exclusively used in semiconductors. You can remember them. And Eka aluminium is known as gallium. Both of them are having L ka sound, LL sound on the second alphabet. So you can use some tricks to remember that. Not difficult. Okay. Another achievement, noble gases were not discovered, but once they were discovered, they were easily kept into the table without disturbing it. Okay, so zero group हमने नाम दिया like Mendeleev, and he kept all the noble gases over there. Okay. Okay, so zero group में without disturbing the table we kept them, but there were some limitations. That is why today we don't stick by Mendeleev's periodic table only. We study the modern periodic table. So what would be that we can see? Okay, yeah, देखो. The first thing is that at some places in the table, the sequence of increasing order of atomic masses was distorted. He said that we are going to arrange the elements in increasing order of atomic masses, but that was not being followed everywhere. Pay attention, cobalt and nickel. Cobalt is having atomic mass 58.9, nickel 58.7. So what do you think should be kept first? Yes, बताओ कौन पहले आना चाहिए? Cobalt, can you see that? I guess I have, yeah. So what do you think? Which of these should be kept first? Here you see cobalt with 58.9, nickel with 58.7. increasing order of atomic mass, and nickel should be kept before cobalt, but the sequence was disturbed. Now pay attention to tellurium and iodine. Tellurium has a mass of 128, iodine 127. Oops, ये तो झोल हो गया. This is गड़बड़ है ना. So what was the reason? What do you think, Mendeleev? Like by mistake he did it? He intentionally did it because he knew, he saw that cobalt was resembling rhodium and iridium, and nickel was resembling palladium and platinum. So instead of giving priority to maintain the increasing order of atomic masses, Mendeleev gave priority to the chemical properties. So he clearly stated that I want to keep elements with the similar properties together in the same group, and that is why he kept cobalt before nickel. He saw that cobalt is resembling rhodium and iridium, nickel with palladium and platinum. The same happened with tellurium iodine also. So at some of the places, in order to satisfy the chemical properties wala agenda, there were some sequence that were distorted. Okay, so that was the first point. The next is position of hydrogen is not fixed. He was like, I don't know what to do with hydrogen. Hydrogen resembles alkali metals. Alkali metals like sodium that can lose its one valence electron very quickly in order to attain an octet. Hydrogen has only one electron that it can lose very easily to make a proton. So this tendency to lose the electron very easily resembles alkali metals, and it is a non-metal. Hydrogen non-metal, it resembles the halogens also. They are also, you can see, diatomic in nature. You see hydrogen is diatomic in nature, so it should belong to halogens or alkali metals. He was confused. So position of hydrogen was not fixed, and this is even not now fixed. Modern periodic table, maybe there's a limitation. The next was isotopes of all elements posed a challenge to Mendeleev's table. Exactly. So what are isotopes? Isotopes are atoms of the same element. You see, I have taken carbon element. It is having a lot of atoms. So some carbon atoms are having a mass of 12. Some of them have mass 13. Some of them have mass 14. So isotopes are atoms of the same element possessing the different masses. So they have different masses, no problem. The next thing, because isotopes have same atomic number, so they have same number of protons, same electrons, same valence electrons, they have same valency. Okay, that means they have same chemical properties. So the point is that isotopes are having same chemical properties, but the masses are different. So Mendeleev was like, how will I arrange them? Because his table was asking to arrange the elements in increasing order of atomic masses. So if he keep carbon 12, 13, 14 in different groups, but that means different group means different chemical properties, but they have same properties. So if they have same property, they should be kept together at the same place, but their mass is different. How can he keep them at the same place? So he was confused what to do with isotopes. So this was the limitation, and this finally led to the discovery of the modern periodic table. Okay, that we will be discussing now and is very important. Fine. So I hope you have understood everything by far. Okay, so let's get started to the next thing. Once we're done with the limitations of Mendeleev's periodic table, now we know that this is not a solution. So we need to have some another, classification that can solve all the problems that we were facing. So finally the next scientist that came into the picture was Henry Moseley, and Henry Moseley had given a major contribution to classify the elements, but he clearly stated that I am seeking inspiration from Mendeleev's periodic table. So you can see that what Henry Moseley did, he took the table that was prepared by Sir Mendeleev and he exactly arranged the elements in the same way. So it was, to a very significant level, he took help of the Mendeleev's periodic table. So what we have today might not be possible if Sir Mendeleev didn't give that classification. classification. So that is why we say that his contribution is significant, and just to pay him tribute, there is an element with atomic number 101, that is Mendeleevium, that is named after Sir Mendeleev, just as a token of respect that we are giving, right? So now what was the change, like where the major change was coming? So you have seen by now that all the earlier classification, there's a one simple common parameter that you will see, and what was that? That was the atomic mass. Right, so if you talk about Newland, you talk about Dobereiner, even you talk about Lothar-Meyer curves, that is something you'll do in 11th. So, and including Mendeleev, all these scientists have been by now just arranging the elements in increasing order of atomic masses. And Moseley was like, quite smart. He was like, all these famous scientists, they have been doing some major mistake, and that is something he took a major step there. Instead of taking atomic mass as a fundamental property, what did he do? He took atomic number as a fundamental property, right? And not just that, he did the X-ray spectroscopy, and then he confirmed that atomic number is a better fundamental property. You can see that atomic number of an element never changes, and no two different elements can have the same atomic number. That is its individual identity. Just say you have your Aadhaar ID, right? So Aadhaar ID of every citizen of India is different. In the same way, you see atomic number of every element is different, because that is signifying the number of protons. So another point, you can see it is always a whole number. So there is no way that we are gonna have it in terms of the fractions or in decimals. So what did he do? Moseley said that this time we're going to arrange the elements in increasing order of their atomic number, and on doing so, elements having the same properties were repeating themselves. Now, how is it possible? And ma'am, what was the repetition? We need to understand how exactly can we say that. So you can see that when the elements were arranged in order of increasing atomic numbers, that is how we designate atomic number. So that led to the classification of the modern periodic table. And what was the common parameter? Then if you see all the elements which are lying in the same vertical column, they were found to have same number of valence electrons. Yes, you see all the group 1 elements will be having one valence electron. You see the configuration of lithium 2 1. You see potassium sodium 281. You see potassium 2881. So what common thing do you see? Valence electron are repeating. So if valence electrons are being repeated for elements in a respective vertical column, that means they all will be having same valency, and valency is the combining capacity of an element. That is clearly telling us about the chemical property. So that means there is similarity in the chemical properties of these elements. So that is how, if you see the modern periodic table, how the elements have been arranged in increasing order of atomic number, or we can say in increasing order of number of protons. That is atomic number. So he also gave a law. Law can also be asked in exam for 1 mark. You have to be ready for it. Define or give the modern periodic law, that was given by Henry Moseley, which stated that properties of elements are periodic function of their atomic number. That means if we arrange elements in increasing order of atomic number, that like you have done here, elements with the same property, similar properties were found to repeat themselves. And how that repetition was coming? In a vertical column, it was seen that all the elements were having the same number of valence electrons. That means same valency. That is responsible for the chemical properties. So similarity in chemical properties in the respective group that you can see. So why I am calling it group? Because these vertical columns were given a name groups by him. Okay, so vertical columns are known as what? Groups. So how many groups are there? 18 vertical columns you can see, starting from 1, 2, 3, 4, 5, so on, and this is your last group, group number 18. Okay? So how many vertical columns? 18 groups. Then horizontal rows. How many horizontal rows? 7. These are the horizontal rows: first, second, third, fourth, fifth, sixth, and 7. Right, so 7 horizontal rows known as periods were there. And yeah, remember this word, they are known as periods. Okay, so 7 periods and 18 groups were there in the modern periodic table. And if you watch out the group number 1 elements, they all have 1 valence electron. So that means their valency will also be 1. You see group 2 elements, all of them have 2 valence electron, the valency will be 2. Group 13 elements are having a valence electrons of 3. Group 14 के valence electrons are 4, group 15 have 5 valence electrons, group 16 have 6, group 17 have 7 valence electrons, and group 18 elements have 8 valence electron. Also calculate the valency 1, 2, 3 and 4. So when valence electrons are 4 or up to 4, then valency is equal to valence electrons. And if valence electrons are above 4, then valency is calculated by subtracting valence electrons from 8. So you can see 8 minus 5, 3 is the valency of group 15 elements. 8 minus 6, 2 is the valency of group 16, 1 is the valency of group 17, and 0 is the valency of noble gases. Apart from that, there is also a name that every group has been given, and you know that group 1 elements are known as what? Alkali metals. Right? Why do we call them alkali metals? The reason is that alkali are water soluble bases. So when you talk about group 1 metals, I am going to change my position. See. If you talk about group 1 elements, let's say I have taken lithium. Now when we are adding them into water, then in water they give us water soluble bases. Lithium hydroxide that you would be getting, it is a water soluble base, and that too strong. Okay, water soluble bases are something that we define as alkalis. So when we take these metals in water, they are going to give us very strong alkalis. So they are known as alkali metals, except for hydrogen. Hydrogen is a non-metal, so you cannot call it as an alkali metal. So if someone asks you how many alkali metals are there, so your answer should be 6. Lithium, sodium, potassium, rubidium, cesium and francium. Hydrogen is a non-metal, remember that. Okay, similarly on the same note, group 2 elements. Group 2 elements are known as alkaline earth metals. Alkaline earth metals, the name earth is coming from the fact that most of them are obtained in the earth's crust. They are found in the earth's crust. Okay, and alkaline, why? Because even if you take the group 2 metals, just say I have taken magnesium, when we dissolve them in water, then they will also be giving us water soluble bases, which are known as alkalis, but their water soluble bases are relatively weaker. So they don't give us strong alkalis, they give us weaker alkalis. Okay, so that is why they are known as alkaline earth metals. Easy peasy, you can have a look at that. Then we have group 13 element. They are simply known as boron family because the head element, the head member of this group is boron. So starting from there, and this is a very confusing group. So you know the same thing is not always being followed here, and the octet completion is also very difficult. So if you talk about boron, that is a semi metal. You will remember this, right? It is a metalloid. Don't think that it's a metal. Right, I guess everything is visible. Fine, I'm not covering the screen. Fine, very good. The next thing, remaining elements in this group are metals. Okay, then we have your best group that you've done in the last chapter, all about carbon, that leads to the formation of organic chemistry. So carbon, this group number 14 elements are known as, this is carbon family. Starting with carbon, and they always are involved in making what kind of bond? Covalent bond, because they have a valency of 4. So it's not possible to lose or gain 4 electrons, so better they would like to share the electrons. So they are always involved in making a covalent bonding. Then you are having your group 15 elements. Group 15 element, the nitrogen family is known as nicogens. The spelling may N and T, P and T is silent. Nicogens. Okay, nicogens means suffocating. So they have a very suffocating odor. They have a choking smell. So you can say choking or suffocating, and they are like nitrogen, phosphorus. You cannot come in contact for a longer period of time like that directly. So they have a choking odor. Now talking about group 16 elements, they are the oxygen family. And can you tell me in the comment section what do we call them? Chalcogens. ठीक है, इनका नाम होता है chalcogens. And why do we call them chalcogens? Chalcogen means ore forming. So most of the ores of elements, especially metals, they are either found in the oxide form or in sulfide. जैसे if you see aluminium is found in the bauxite ore. So the anion part there is oxide, है ना. You see mercury exist as sulfide, right? And if you talk about zinc भी sulfide में exist करता है. So most of the metals that you see are either oxides or sulfides. Ore, that is how their ores are existing. So we call them chalcogens. And then you have group 17, the fluorine family. They are known as halogens. Why do we call them halogens? Because they are salt forming. So majority of the salt that you see, they will be having the anion fluoride, chloride, bromide, iodide. Not astatine ko you can still leave. The next one, group 18 elements, have a lot of name, and I want you to give me the answer in comment section. Group 18 elements are known as noble gases, zero gases, and two other names I guess you can tell me. Tell me why, right? If inert gases, they are already stable. They're like, dude, we have a dream electronic configuration. Why would we even want to react? So that was a chotu sa, just a small, very minor say points about the modern periodic table. And you should remember, elements have been arranged in increasing order of atomic number, and this table was prepared by whom? Niels Bohr. Niels Bohr helped to prepare the modern periodic table, right? Also to keep the configurations of the elements, and mostly he gave the entire idea, the law, and how we have to arrange the elements and everything. So how the limitations of Mendeleev were being overcome by the table. The first point, cobalt and nickel ka problem was solved. So you remember cobalt and nickel mein there was a problem that was coming in the case of the Mendeleev's periodic table, but that was solved now. Cobalt has atomic number 27 and nickel has atomic number 28. ठीक है, बट वहां पर क्या हुआ था, निकल विद यू कैन सी द मास में देयर वाज गड़बड़ ना. कोबाल्ट वाज हैविंग मोर मास देन द निकल, right? So according to Mendeleev, nickel should be kept before cobalt, but was this the case? No, cobalt was kept before nickel because of similarity with the elements. But here the problem was solved, because even though cobalt has slightly higher mass than nickel, but atomic number of cobalt is less than that of the nickel. So because this is increasing order of atomic number, so we don't have to worry about the masses. So cobalt with the low atomic number is coming first, nickel with higher atomic number is coming after it. So there is resemblance in chemical properties of elements, as well as the order of atomic number is being justified here, right? So that was not an issue over there. So the first point was stated. The next, position of isotopes were clear. ये बहुत अच्छा point है. So isotopes में there was a problem that was coming, है ना? How the problem was coming? Because isotopes are the atoms of the same element having different masses, like carbon atoms with mass of 12, 13 and 14. And we know that isotopes are having the same chemical properties. Atomic number same hai because they are atoms of the same element, right? So there was no problem in keeping or arranging the isotopes, because all of them are having the same atomic number as well as same chemical properties, so they could be kept together at the same spot in Mendeleev's period, in the modern periodic table. And this is what that happened. Okay, so position of isotopes was justified. All the isotopes were kept at the same place in modern periodic table. Why? Because they have same atomic number and same chemical properties. Okay, तो कोई problem नहीं था. Okay, the next one. It is possible to predict how elements could be discovered between the two elements. Now, there was a problem that was not very much clear in the case of Mendeleev, although ये बहुत difficult problem नहीं था. The next one, position of hydrogen, that was being resolved, although that is not completely resolved over here. Okay, hydrogen got a fixed position now, group number 1, but hydrogen at least know where I have to go. So last year sample paper mein this question was given, that why hydrogen resembles metals. So something like that. So you know that hydrogen has only one electron with it. And just like metals, hydrogen has quite strong tendency to lose this electron and make a proton H+. So because of its high tendency to lose an electron quickly, we are keeping it with group number 1. Although this is not clear yet, this is a drawback in modern periodic table, but that's how we are living right now. If you have a solution, think about it. You might win a Nobel Prize someday, okay? Okay, think around it. So apart from that, I've told you how similarities coming in the elements which are falling in the same vertical column are having the same number of valence electrons, है ना? And that means same valency, same number of the, you can say over there, the chemical properties basically. Apart from that, यहाँ पर कुछ blocks भी हैं. See, group number 1 and 2 elements are known as S block elements. This is something you'll do in 11th class, but just for information, S block elements, why do we call them? Because the last electron enters into the S subshell. जैसे you have the KLMN subshell, KLMN shells are there. These shells are further divided into subshells like S, P, D, F, G, etc. And when an electron enters into a subshell and when it's entering into the last electron enters in S subshell, those elements are kept in S block, okay? And यहाँ पे group number 3 to 10, because their last electron enters into the D subshell, so they are known as D block elements. Group 13 to 18, their last electron except for helium enters into the P subshell, so they are known as P block elements. Right, then यहाँ पर ये जो होते हैं lanthanides and actinides, these like 14 elements which are coming in lanthanides and 14 in actinides, they are kept in the F block. They are known as F block elements because their last electron enters into the F subshell. Right. Okay. Now apart from that, you need to understand this point also कि lanthanides जो है, these 14 elements which are actually starting from cerium. Starting from atomic number 58 cerium to atomic number 71 lutetium, they are a part of period number 6. 6th period and 3rd group. So lanthanides belong to which period? 6th period and 3rd group. 6th period, 3rd group, and these are the series of 14 elements. They are the first lanthanide series, right? Lanthanide क्यों बोलते हैं? Because they are coming after lanthanum, ठीक है? They are just after lanthanum, so because of that lanthanides, and these starting from thorium atomic number 90 to lawrencium, they are actinides. Now they are kept into the 7th period, okay, and 3rd group again. So just to avoid the anomalous expansion in the periodic table, and because there is one common point, the last electron for all these elements enter into the F subshell, so we have kept them separately in the F block. Okay, so I guess that is clear. And D block elements are also known as transition elements. Transition elements, the reason is that because their properties are transitional properties between metals and non-metals. जैसे यहाँ पर if you see on the left of the transition elements, you see metals. They are electron donors. Okay, they have properties very different from what elements kept on their right hand side. So it's like a bridge that you are crossing and you enter a different world. Array, these elements were losing the electrons, all of a sudden these elements are now gaining the electrons. The left wali side mein there was ionic bonding, now right mein they are making covalent bonding. What is happening? So they are like transitional properties are being shown on their left and right. They are known as transition elements, and F block elements को बोलते हैं inner transition elements. Okay, inner transition again because यहाँ पर भी transitional property, and on the inner side if you see they are kept over here, है ना? So मतलब they are coming वैसे वहाँ पर, so their properties are like inner transition, so they are known as inner transition elements. Okay. The elements in a group contain same number of valence electrons. We have discussed this point. The groups in the periodic table signify the identical outer electronic configuration. Ma'am has told you lithium ka configuration 2-1, sodium 2-8-1. So the outer electronic configuration is similar for all the elements in a respective group. Okay. Okay, importance. The number of shells increases as we go down the group. Yes, as you are going down in the group, just say lithium is kept in the second period. They have 2 shells. You go to sodium, sodium is kept in third period. They have 3 shells. Potassium kept in fourth period, 4 shells. Rubidium in fifth period, 5 shells. Cesium in sixth period, 6 shells. Okay, then you go to francium, will be having 7 shells. So what is happening when you are going down in a group? This was a group number 1. When we move down in a group, then we see number of shells are increasing. Although elements are having the same number of valence electron, मतलब valence electron सब में एक है, 1 1 1 1 1, but they contain different number of shells. ये तो आप कर सकते हो. Period number tells you the number of shells. If you want to know the period number of an element in the modern periodic table, you can simply see how many shells it is having. Write the configuration. देख लो कितनी shells हैं उसके पास. You will know the answer. Right? Okay. The next thing, I guess it's fine. Ma'am is visible to you. Yeah, the next is period में अगर आप देखोगे, what is happening, period is that horizontal row that ma'am was saying. So the elements of valence shell, the number of valence shell electrons are increasing by 1 unit in the period. Why? Because atomic number is increasing on left to right. Yeah, that is fine. जैसे you see the यहाँ पर देखो. So what is happening? Lithium, beryllium, boron, carbon, nitrogen, oxygen. So there is an increase in atomic number by 1. क्योंकि इंक्रीजिंग ऑर्डर है ना. सिर्फ लिथियम हैज एटॉमिक नंबर 3, बेरिलियम 4, बोरोन 5, कार्बन 6, नाइट्रोजन 7, ऑक्सीजन 8, फ्लोरीन 9, नियॉन 10 एंड सो ऑन. इंक्रीज हो रहा है बट नंबर ऑफ शेल्स विल रिमेन द सेम. Okay, atoms of different elements with the same number of occupied shells are placed in the same period. I have told you. Just if you talk about the same one, lithium, beryllium, boron, carbon, nitrogen, oxygen, they all are having 2 shells. See the configuration: 2 1 2 2 2 3 2 4 2 5 2 6 2 7 and 2 8 for neon. Right? So if you see, they all are having 2 shells, so they are kept in the second period. Same period में रखे हैं सबको, है ना. So same number of shells वाले elements are in the same respective period. Now you see the p block elements में you see the maximum variations. Group number 13 to 18 elements, the p block elements, यहाँ पर you will get to see the metals, you will see the metalloids, you will see the non-metals. So it's like, you know, shades that you're watching. So see here. Group 17, I have told you the name. Halogens होते हैं. These are noble gases, rare gases, inert gases, zero group. So you have seen oxygen family, chalcogens, you've seen nicogens, right? And ये green color से जो zigzag diagonally आप देख रहे हो, they are your metalloids, the property between metals and non-metals. Blocks, ma'am has already told you, on the basis of the subshell in which the last electron is coming. Okay, just on that basis. The next is periodicity. Now this is where the major important part of the chapter is going to start. Okay, and यहाँ से question will be coming. So the periodicity that we are talking about repeatedly, what is that? Now this periodicity is the repetition in something, है ना. So when a property, when a function is being repeated, we say it is a periodic function. So periodicity is caused by regular and predictable variations in the atomic structure and electronic configuration. So you have seen that when we arranged elements in increasing order of atomic number, then we just found that elements in the same respective group were having the same number of valence electrons. We saw elements in the same group आप देख चुके हैं in the same period. You can see there's an increase in atomic number by 1. The elements which are falling in the same period are having same number of shells. So there is some repetition. Right. So because of these, you know, regular predictable variations, there are some properties which are being repeated in the elements, and that is what we study. And the major repetition किसकी वजह से है? Similar electronic configuration of elements in a respective group. So what are those properties, how they are being repeated, that we're going to understand. The first one is the trend of valency across the period and down the group. So both side variation we have to see. तो आप valency के केस में देखो, I've told you already, group 1 elements are having valency 1, Group 2 elements, 2 valency. Group 13 have 3. Group 14 have 4. Then group 15 have 5, 6, 5 like valence electrons. तो valency निकाल सकते हो. देखो ऐसे कर लो. Write the valence electron first. Group 1 is having 1 valence electron. So their valency will be 1 only. You know this. How to calculate valency? Write the electronic configuration. See the valence electrons. If valence electrons are less than equal to 4, in that case valency is equal to valence electrons. And if you see valence electrons are more than 4, then in that case valency is equal to 8 minus valence electrons. इतना भी करने की ज़रूरत नहीं है. I can tell you directly. Write the configuration of nitrogen. 2, 5. Nitrogen is having 5 valence electrons. That means if nitrogen wants a nearest noble gas configuration for the stability, nitrogen को क्या चाहिए? Just 3 more electrons. 5 तो है उसके पास. It requires 3 more electron to complete an octet. So उसका valency 3 है. Because on gaining 3 electrons, it will get an octet. है ना? Okay. Now you see sodium. Sodium has configuration 281. Now to get a nearest noble gas configuration, sodium needs to lose 1 electron. If it loses 1 electron, it will get a neon type configuration. So उसका valency 1 होता है. आप directly भी कर सकते हो. It's not like you have to always use formulas. Directly कर लो. वरना group 1 elements have a valency 1. Group 2 elements 2, group 13 3, group 14 4. So what is happening to the valency? First valency is increasing left to right across a period. Valency first increases up to group number 14. Group 14 की valency 4 होती है and then it decreases. Decreases कैसे? Nitrogen has 5 valence electrons, so valency is 8 minus 5, 3. Then oxygen family are having 6 valence electrons. So valency 8 minus 6, 2. ठीक है. Fluorine family 1. And noble gases to 8 minus 8, 0. They have 0 valency. So what is happening to valency? It first increases up to group number 14. Then it decreases. Right. And valence electrons, they keep on increasing. So the trend in valence electrons and valency, दोनों आप देख सकते हो left to right. Okay, now why we have shown the signs here? It's not important to show plus or minus in valency. आप simple neutral number बता सकते हो. But if you want to see charges, because valency determines the charge also, na? And whenever an element is losing the electrons, it gets a positive charge. So why we have shown plus 1 for group 1 elements? Because they prefer to lose 1 electron and get stabilized. So plus 1. Okay, जैसे magnesium is 282, it would prefer to lose the 2 electrons, तो plus 2 valency sign के साथ दिखाया है. जैसे group 16 elements, oxygen है 6 valence electron, its valency is also 2, but it needs to gain the 2 electrons, so it will have minus 2 charge. Are you understanding? Group 2 element जैसे magnesium है and यहाँ से oxygen है, both of them are having valency of 2. डिफरेंस क्या है? डिफरेंस ये है, मैग्नीशियम इज अ मेटल, इट्स वैलेंसी विल डिटरमाइन अ पॉजिटिव चार्ज because on losing 2 electrons it will get a positive charge, है ना? And oxygen on gaining 2 electrons will get a octet. So that is how valency helps to determine the charge also, whether electrons are lost or gained. Accordingly we give the sign. जैसे nitrogen is gaining 3 electrons for the octet completion, so उसके लिए negative 3 होगा. ठीक है. Sodium is losing 1 electron, it would be plus 1. You understanding? But trend is very much simple. कर सकते हो. So how valency vary in a period on going from left to right? It first increases and then decreases. First increases कहाँ तक? Up to group number 14. Group 14 elements have maximum valency 4, है ना? And then it decreases up to 0. How valency vary in going down the group? Down the group तो valency will remain same because number of valence electrons are same. कर सकते हो? Easy peasy, not difficult. Easy है, you all can do it, I know that. The next is atomic size. Before doing the trend of atomic size, you should know कि है क्या atomic size, है ना? This is also important. So atomic size होता है when we are having an atom then from the center mein we do have nucleus. So you have to take the distance of center of nuclei up to the last electron. I'm going to draw here. Shilpi ma'am's drawing is very bad. This is nucleus and this is the valence electron. So how do we measure atomic size, atomic radii? We take the distance of center of nucleus and we go up to the valence shell. ये distance atomic radii होता है और atomic size. Distance between the center of nucleus and the outermost shell, valence shell. Now definition is not complete. This point is very important. Of an isolated atom. अब ये क्या बता रहा है? Isolated atom मतलब when atom is not bonded to any other atom. Atom should be free. It should be not bonded to any other thing. जैसे यहाँ पर दिखाया उन्होंने, it's a molecule, है ना? So what is happening over here? जब भी कोवेलेंट बॉन्ड बनता है, then let's say this is nucleus of one atom, this is nucleus of another atom. So in that case, how do we measure the radii? Covalent radii वहाँ पर measure होता है. That is the covalent radii that we measure. We take the distance of center of the two nuclei यहाँ से. This is known as internuclear distance. Distance between the two nuclei. ठीक है, internuclear distance we measure, then we divide it by 2. Internuclear distance को 2 से divide कर दो, then we get the radii. But this radii is not appropriate because whenever there is a bonding, जैसे covalent bond हुआ, there is always overlapping of orbitals. जैसे this is one atom, this is another atom. So there is some sharing that is taking place. So in that case, when you take out half of the internuclear distance, you don't get the exact radii. That is smaller than the actual radii of an atom. So we don't take it in the bonded state. इसीलिए हमने लिखा है that this is the distance of the center of nuclei up to the valence electron of an isolated atom. मतलब it should not be bonded to any other atom so that we can get the exact precise measurement instead of measuring the covalent radii. That is something we do in the covalent bonds, ठीक है, of the molecules. Okay, now what is the trend of the size across a period? Along a period, what happens? जैसे देखो ग्रुप नंबर ग्रुप का ट्रेंड बाद में देखते हैं. वॉच द पीरियड, सेकेंड पीरियड एलिमेंट्स आई एम अरेंजिंग नाउ. बोरोन, बोरोन से शुरू करोगे? नो मैम, वी विल स्टार्ट फ्रॉम लिथियम. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Only up to group 17 we are taking. We are not talking about the noble gases right now. Okay, ठीक है. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. What is happening? You know, atomic number is increasing. Atomic number of lithium is 3, beryllium 4, boron 5, carbon 6. So atomic number क्या बताता है? Number of protons. Number of protons in the nucleus of an atom. And that in a way tells you about the nuclear charge. So can we measure the nuclear charge? Yes. Ma'am, you are not visible. It's fine now. Yep. Okay. So I was saying कि what is happening when you are going left to right across a period. Left to right जाने पर क्या हो रहा है? Atomic number is increasing. And let me explain you the nuclear charge first of all. यहाँ पर आ जाओ एक बार. Let's understand the nuclear charge. Okay, because size of an atom depends on the two factors. The first is nuclear charge and the second is number of shells. These two factors, they determine the atomic size ka trend. Now what is nuclear charge? Nuclear charge, the name itself is telling you charge in the nucleus. Charge in the nucleus of an atom. This is an atom, this is the nucleus. Why nucleus has charge? Because of protons in it. Protons are responsible for giving it a charge. Neutrons to neutral hote hain. So why nucleus is having charge? Because of protons. So number of protons in an atom determine the nuclear charge. Just if lithium is having 3 atomic number, it has 3 protons in the nucleus. So its nuclear charge is +3. Charge in the nucleus is nuclear charge. That is coming because of the number of protons. So jitne protons hai, that is the nuclear charge. है ना? Beryllium is having a nuclear charge of +4. Yes, boron is having +5, carbon +6, nitrogen +7, oxygen +8, fluorine +9, because fluorine nucleus is having 9 protons in the nucleus. So now what do you think? If nuclear charge is more, then what will be the impact? How is that going to impact the size? Dekho, nuclear charge is more, that means nucleus is having more number of protons. If nucleus has more protons, you know that electrostatic forces of attraction says that positive charge always attract the negative charge. So it means there is some force of attraction between nucleus and the electrons of an atom. Nucleus is always attracting all its electrons. There is a pull that is exerted by nucleus on its electrons. So if nuclear charge is more, that means if nucleus is having more number of protons, then that means the nucleus will strongly pulling the electrons towards itself. है ना? So if I am comparing two atoms, let's say lithium के nucleus में there are 3 protons and fluorine nucleus is having 9 protons. So nuclear charge of fluorine is clearly more than lithium. है ना? So it means that fluorine nucleus will be pulling the electrons more tightly towards itself. So nuclear charge कहाँ ज़्यादा है? In the case of fluorine. Now what is effective nuclear charge? There's a term that you will continuously use, effective nuclear charge. Effective nuclear charge is, it's the nuclear charge that we talk about with respect to the valence electrons only. Like this is the nucleus, this is first shell, second shell. Okay, so how much attraction from the nucleus are the valence electrons experiencing? That is effective nuclear charge. How much pull, I'm talking about just the valence electron, they are experiencing, that is effective nuclear charge. And effective nuclear charge is always less than the nuclear charge, because internal electrons are always, they are causing a hindrance. अगर आप एक तरह से देखो, they are shielding the valence electron. So what charge should be experienced by valence electron? उससे थोड़ा कम experience करते हैं वो, because of shielding done by the inner electrons. So effective nuclear charge is in terms of valence electrons only that we talk about. Okay, so that is nuclear charge. So when you are going left to right across a period, what is happening? You can clearly see number of protons are increasing, effective nuclear charge is increasing. So if effective nuclear charge is more in the case of fluorine, that means fluorine nucleus will be attracting the valence electrons more tightly, as a result of which size of fluorine will decrease. ठीक है, इतना ज़्यादा पुल हुआ, that size is gonna decrease to some extent. And if you talk about lithium, lithium has got only 3 protons, less effective nuclear charge. So because of less effective nuclear charge, valence electrons are not tightly attracted. So in this case, the size of lithium is bigger as compared to fluorine. So when we go left to right, size of an atom decreases. The reason, effective nuclear charge keeps on increasing, and that means the valence electrons are pulled more tightly by the nucleus. Hence we can say size decreases. Now second parameter that ma'am was talking about was number of shells. Ma'am, is it not impacting the atomic size along a period? No, because along a period number of shells are same. Lithium is having 2 shells, beryllium 2 shells. ठीक है, बोरोन हैज अ कॉन्फिगरेशन 2-3, कार्बन 2-4, ऐसे करके फ्लोरीन 2-7. सो नंबर ऑफ शेल्स आर सेम अक्रॉस अ पीरियड, है ना. दे ऑल आर हैविंग सेम नंबर ऑफ शेल्स and electron is entering into the same shell every time. It's not that electrons नहीं बढ़ रहे, electrons are also increasing, but each time electron is entering into the same shell. So that is not creating any problem. Number of shells same है, but effective nuclear charge is increasing. That leads to a decrease in the size. So we can say this is due to increase in the nuclear charge. Effective nuclear charge will be better, which tends to pull the electrons closer to the nucleus and reduces the size of an atom. Easy है, कर सकते हो. Okay, the atomic size increases down a group. Yes, down a group, जैसे if you talk about lithium, sodium, potassium, rubidium, cesium, francium. Lithium second period element है, it is having 2 shells. Sodium is having 3 shells. Now francium is 7th period element, 7 shells. 1, 2, 3, 4, 5, 6, 7. So what happens? Effective nuclear charge is less here. है ना, because nucleus and valence electron का distance has increased so much because of increase in shells that nucleus is not even able to see its valence electron. So the nuclear charge is not impacting here. What is the factor contributing in the size is the number of shells, because when we are going down in a group, number of shells are continuously increasing, new shells are being added, so that means the distance of the center of nucleus and the valence electron significantly increases. So atomic size along a group, it increases. Okay, so it's written here, number of shells are increasing, shielding increases and atomic radii increases. Shielding increases, समझ रहे हो ना अब, this is nucleus, this is valence electron. Now more and more electrons are shielding the valence electron. So what should be the effective pull that the valence electron should feel that it is not able to feel, because अंदर वाले electrons are repelling that, they are causing a shielding, they are not letting the valence electron experience the same kind of love from the nucleus that they are getting, है ना. So what happens, atomic size increases. Okay, so one more thing I would like to the ionic radii का trend would be same, a longer period left to right decreases, top to bottom increases. A question I'm gonna give you guys, homework, ठीक है, लिख लो एक बार इसको, that you will be doing it. The homework is that you have to compare the size of cation to a neutral atom, okay, and anion to a neutral atom. So you should know that cations are always smaller than the neutral, their parent atom, and anions are bigger than the parent atom. The reason is that अगर आप यहाँ पर देखोगे सोडियम प्लस के केस में there are 11 protons attracting the 10 electrons. Neutral sodium में 11 protons are attracting the 11 electrons, it's balanced. But when you remove one electron from sodium, there are just 10 electrons and nucleus 11 protons. That means the effective nuclear charge increases here. Effective nuclear charge cation में increase हो जाता है. So because of that, pull of the nucleus becomes stronger and size decreases. So cations are always smaller than their respective parent atom. And anion में देखो fluorine के case में 9 protons are attracting the 9 electrons. Now here fluorine has gained 1 electron. So 9 protons have to look after 10 electrons. They cannot effectively do it. So जिसकी वजह से effective nuclear charge decreases, that is impacted. Okay, so you can say size बढ़ जाता है यहाँ पर. Okay, so exam में the questions can be asked from there also. You have to pay attention. Okay, very good. The next property is metallic and the non-metallic character. Very easy, just like you can use your brain and just remember these trends very easily. Now what is metallic character? Metallic character is tendency of an element to donate the electrons, है ना, in a chemical reaction, to lose the electrons. जैसे if you talk about sodium that has one valence electron, it can lose easily. If you talk about let's say आपने aluminium लिया, ठीक है, या फिर आप क्लोरीन ले लो 287, it cannot lose 7 electrons easily can't lose 7 electrons. So how you define a metallic character, that is the ease of an element to donate its electron. If an element is easily able to donate the electrons, we say that it is more metallic. Okay, and non-metallic nature क्या होता है? That is opposite, ease with which an element can gain the electrons. If element is easily able to gain the electrons, it is more non-metallic. So if you pay attention to the periodic table, then if you watch carefully when you go from left to right, यहाँ पर the moment you reach the right hand side, majority non-metals you get there. Oxygen, carbon, fluorine, chlorine, nitrogen, they all are non-metals. And left hand side को ना metals होते हैं. So that means when we go left to right across a period, metallic character decreases. How are we going to understand that? The same points we would be discussing. देखो, now this, see what is happening. Lithium, second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Not talking about noble gases, they're not going to take part in our trends. Lithium has a configuration 2-1, fluorine has a configuration 2-7, है ना. So you know that lithium के case में there are 3 protons that are attracting the valence electron. Fluorine में there are 9 protons which are attracting the valence electrons. So we know that when we are going left to right across a period, effective nuclear charge increases. Effective nuclear charge बढ़ रहा है ना, because number of protons are increasing. So that means nucleus will be attracting the valence electron much tightly in the case of fluorine as compared to the lithium. So if nucleus is tightly attracting the valence electron, in that case it is difficult to remove the electron. Yes or no, everybody in the chat box? मुश्किल होगा ना यहाँ से. If you want to take this electron out from the fluorine, where the nuclear charge, the 9 protons are attracting the valence electrons, the effective nuclear charge is so high. So it's like, dude, you cannot take out electron from us. So metallic character decrease होता है, ठीक है. So you know, left to right, effective nuclear charge increases, atomic size decreases, because of which nucleus attracts the valence electron more tightly and it becomes difficult to remove the electron. To lose the electron becomes difficult. So we say metallic character decreases. Okay, so remember that effective nuclear charge से inversely proportional है atomic size, and similarly it is inversely proportional to metallic character. If effective nuclear charge increases, metallic character and atomic size decreases. ठीक है. And उल्टा इसका, the non-metallic character, that would be increasing because that is the ease with which element can gain an electron. Non-metallic property में आप gain करने की बात करते हो. If electron is gained easily, it is more non-metallic. So fluorine के case में, because the effective nuclear charge is very high, so if fluorine has to gain one electron, nucleus will be able to hold it easily. Nucleus will be able to attract it easily. ठीक है. It's like a frog, a hungry frog जो side में, you know, who watches flies and immediately just take it, okay, inside. So the same thing is fluorine is that frog and electron is that fly जो उसको दिखा है उसने बिल्कुल एकदम एनगल्फ कर लिया, राइट. सो नॉन मेटालिक कैरेक्टर पे क्या असर पड़ रहा है? नॉन मेटालिक कैरेक्टर इंक्रीजेस बिकॉज इफेक्टिव न्यूक्लियर चार्ज बड़ा है ना. सो न्यूक्लियस विल बी एबल टू अट्रैक्ट द इनकमिंग इलेक्ट्रॉन इजीली, एंड लिथियम के केस में इट वुड बी डिफिकल्ट. So when we go left to right across a period, metallic character decreases, non-metallic character increases. That is why on going left to right, जब आप left to right जाते हो, then you see metals से सीधा metalloids, then non-metals, है ना. बीच में you are having metalloids, then यहाँ की side you have the non-metals, right. So you can see that how the trend is changing. What happens along a group? Metallic character along a group क्या होता है? Down the group effective nuclear charge is decreasing, है ना. We have seen what is the case down a group, the number of shells. यहाँ पर second period elements are having 2 shells, है ना, and यहाँ पर they are having 3 shells. Then the 7th period elements 1 2 3 4 5 6 7 shells. So what happens? Nucleus cannot attract the valence electron very much tightly, है ना. So valence electron इतना दूर है, you can easily remove it, right, because the outermost electron is farther away from nucleus, they can be lost easily. So on going down the group, metallic character जो है that keep on, this is across the period. Down the group metallic character increase करता है, ठीक है, because it becomes easy to lose the electron, remove the electron, and opposite non-metallic character decreases. So if francium has to gain the electron, that is not possible because francium nucleus and the incoming electron have a lot of distance. So effective nuclear charge is very less. So francium is like, dude, I'm not interested. So exam में अगर आया, tell me which of these is more metallic, lithium or potassium. More metallic कौन होगा? Potassium. More non-metallic, that would be lithium. So you can do this easily, I guess. Okay, and the same trend you have to follow. जो electropositive आप करते हो, electronegative, that is very similar. The metallic character which ma'am has just explained, you can relate it to the electropositivity also. Electropositive character का trend will also be same. ठीक है. जस्ट द डिफरेंस इज दैट इलेक्ट्रोपॉजिटिविटी क्या होता है. इलेक्ट्रोपॉजिटिविटी इज टेंडेंसी ऑफ एन एलिमेंट टू लूज द इलेक्ट्रॉन एंड मेक अ कैटायन. जैसे दिस इज सोडियम. Sodium has this configuration. So what is its tendency? To lose the electron and make a cation. That is its electropositivity. So if an element is more metallic, means it has tendency to donate the electron easily, it will be more electropositive. है ना. If it is donating the electron, it can make a cation. राइट. सो इलेक्ट्रोपॉजिटिविटी का ट्रेंड भी बिल्कुल सेम होगा, मेटालिक कैरेक्टर वाला. लेफ्ट टू राइट, electropositivity of elements in a period decreases and top to bottom it increases, and you can blame it on effective nuclear charge. ठीक है. and the okay sorry and if you talk about the next point, that is something we have to pay attention. ठीक है. electronegativity जो है वहाँ से आ जाते हैं question, so we always have to be ready with that. okay, how we will be solving the questions. जैसे non metals are electronegative. अब जो इलेक्ट्रोपॉजिटिव कैरेक्टर था दैट यू कैन रिलेट टू द मेटालिक, एंड इलेक्ट्रोनेगेटिव वन यू कैन रिलेट टू द नॉन मेटालिक कैरेक्टर. इट्स द टेंडेंसी ऑफ एन एलिमेंट to gain an electron and make an anion. जैसे you have fluorine. So tendency of fluorine to gain this electron and make an anion is something, it's electronegativity. Remember, it is the tendency only. है ना. So that's the tendency we are talking about. It's not actually gaining it. It's just we are saying that the tendency कितना है ना. जैसे if you see oxygen, oxygen has 6 valence electron, so its tendency to gain the electrons and make an anion. So fluorine is having more tendency to gain the electron because it has 7 valence electron. It just needs 1 more, but oxygen को 2 चाहिए, है ना. So relatively you can say fluorine is more electronegative. So what happens to electronegativity is what happens to the non-metallic character. Left to right we know that effective nuclear charge increases. जैसे फ्लोरीन के केस में 9 protons are attracting the valence electron. So if you have to give 1 electron to fluorine, it can gain it easily and make an anion because its effective nuclear charge is high. So incoming electron can be attracted by the nucleus very easily, है ना. So we say that fluorine is most electronegative element in the entire periodic table, right. Most electronegative है. And if you talk about chlorine, bromine, iodine, यहाँ पे you can compare the electronegativity trend. टॉप टू बॉटम इलेक्ट्रोनेगेटिविटी डिक्रीज करेगा. ठीक है. सो लेफ्ट टू राइट इलेक्ट्रोनेगेटिविटी इंक्रीजेस and top to bottom electronegativity decreases because you have seen number of shells are increasing and the distance of the valence electron and the nucleus increases so much that if this element has to gain an electron, it's very difficult for nucleus to attract it. Electropositivity increase करेगा top to bottom, electronegativity decreases. ठीक है. So you can easily do the trend comparison and this is also important. ये question आ जाता है एग्जाम में. Remember this. Electronegativity क्या है? Tendency of an atom to pull electrons towards itself. So again tendency. ठीक है. From a shared pair in a covalent bond, this is very important. जैसे we have HCl. Hydrogen chloride have a covalent bond where 1 electron belongs to hydrogen और 1 electron chlorine का है. ठीक है. सो इलेक्ट्रोनेगेटिविटी इज टेंडेंसी ऑफ दीज एटम्स टू अट्रैक्ट दीज इलेक्ट्रॉन पेयर टुवर्ड्स देमसेल्फ. लाइक इट्स अ टग ऑफ वॉर. हाइड्रोजन विंस द केस और क्लोरीन, जहां पर ज्यादा पुल होगा दैट साइड इलेक्ट्रॉन पेयर विल बी शिफ्टेड. सो इफ यू वॉच द कॉन्फिगरेशन ऑफ क्लोरीन, क्लोरीन जस्ट नीड 1 इलेक्ट्रॉन टू गेट स्टेबल, है ना, टू बी लाइक अ noble gas. Chlorine has more electronegativity. Hydrogen though it can lose the electron also. Chlorine has very high tendency to pull these 2 electrons towards itself. Okay, so both these bond pair of electrons will be shifted more towards chlorine. They are like, you can say like that, aligned. They are aligned towards chlorine. Because of that it gets a partial negative charge. Hydrogen gets a partial positive charge. So it's a polar covalent bond, right. So tendency of an atom to pull the electrons towards itself from a shared pair in a covalent bond is electronegativity. Okay, and non-metals are electronegative. they have tendency to gain the electron. So you can sum up the trend of electronegativity also. एक बार बता देते हैं यहाँ पर, देखो, let's revise the trends. Left to right atomic size decreases, metallic character decreases, electropositive character decreases. Okay, non-metallic character left to right increases, electronegativity increases. Okay, up to group number 17. Top to bottom atomic size increases, metallic character increases, electropositive character increases. The reason is same for all of them. Non-metallic character decreases, electronegativity decreases. कर सकते हो, easy है. Yes, anti nature, you can just remember them easily by just remembering the one point, effective nuclear charge. Another is nature of oxides. Nature of oxides, dekh lo, this is also important. Nature of oxides, you know that metals are forming the basic oxides. Most of the metals make the basic oxide except for your amphoteric, we are not talking about it, है ना. तो फिर क्या होता है, left to right जाने पर we know metallic character decreases and we know metals form the basic oxide. फिर से सुनो, listen to me again. देखो, when we are going left to right across a period, metallic character decreases and metals make basic oxides. So that means tendency to make the basic oxides also decreases, है ना. तो बेसिक ऑक्साइड्स आपको ना लेफ्ट साइड में मिलते हैं. जैसे यू हैव सोडियम ऑक्साइड, you have seen sodium ka oxide, right? You have magnesium ka oxide. So their oxides, the metals on the left, they are more basic. By the time you go towards the non-metals, chlorine ke oxides dekhte ho, phosphorus ke, sulfur ke, they are acidic in nature, है ना. So what happens, metallic character decreases left to right, metals make the basic oxides, so that also decreases, ठीक है. And we know non-metallic character increase होता है left to right and non-metals make the acidic oxide, so tendency to make acidic oxides increases. So period का trend कर सकते हो. And you know, down the group nature of oxides remains the same, ठीक है. So मतलब all the metals will be making the basic oxide in their respective group and that tendency to make the basic oxides also increases because metallic character is increasing. Metallic character बढ़ता है and metals make the basic oxides, so tendency to make the basic oxides increases. वैसे सब basic बनाएंगे, ठीक है, that remains same, you won't get acidic oxides. And non-metals के case में the acidic nature is gonna decrease down the group. Okay, so watch out this trend. You can relate it to metallic and non-metallic character, easy है. The last point which lot of you leave, the trends in the chemical reactivity, ठीक है. ये कैसे करते हो trend in the chemical reactivity? देखो, when do we call an element is chemically reactive? When it is able to gain the electron easily or lose the electron easily. कोई भी tendency हो, we say that the element is reactive. Either it should be able to easily lose the electron or it should be easily able to gain the electron. That element is said to be chemically reactive. Okay, and if you talk about chemical reactivity, अगर left to right आप जाते हो, देखो left to right I am taking second period elements. Let me see, yeah, देखो second period elements की हम बात करते हैं. Let's say we have taken lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Write the configuration. Lithium has configuration 2-1, beryllium 2-2, boron 2-3, carbon 2-4, nitrogen 2-5, oxygen 2-6, fluorine 2-7. Now lithium has a very strong tendency to lose the electron, है ना, बहुत easily lose कर सकता है electron. Now you talk about beryllium. Beryllium can also lose the electron, but its tendency to lose the electron is less as compared to lithium. Yes or no? Lithium is having only one valence electron, so it's easier to lose one electron rather than to lose the two valence electron. So what do you think? Lithium is more reactive or beryllium? Lithium is more reactive. Okay, now you go to boron. Now it becomes more difficult for boron to lose the 3 electrons. So reactivity is decreasing. Now you go to carbon, carbon gives up. Carbon is like, dude, I cannot lose the 4 electron. So what is happening to reactivity left to right? It first decreases. देखो decrease हुआ है reactivity. The reactivity first decreases on going left to right across a period. Why? Because tendency to lose the electron is decreasing. You can pen it down. Why reactivity is decreasing left to right? Because tendency to lose electrons decreases. Up to group number 14. The moment you reach nitrogen, nitrogen is like, dude, I can gain electrons now. I have tendency to gain 3 electrons. So if you compare reactivity of carbon to nitrogen, nitrogen is more chemically reactive. Why? Because carbon, let's say carbon has to gain 4 electrons, but nitrogen needs only 3 electrons to complete the octet. So reactivity किसका ज़्यादा है? Nitrogen का ज़्यादा है. Now when you go to oxygen, oxygen only needs 2 electrons to gain. Fluorine needs only 1 electron. So desperation for fluorine is more now to gain an electron. So left to right क्या होता है? Chemical reactivity first decreases up to group number 14 and from group 15 it again starts increasing. Okay, why? Because nitrogen, oxygen, fluorine have tendency to gain the electrons. Tendency to gain the electrons increases. So what is the trend of chemical reactivity on going left to right across a period? Chemical reactivity first decreases up to group number 14, then increases. Left to right chemical reactivity में क्या होता है? It first decreases up to group number 14 because tendency to lose the electron decreases. उसके बाद it increases. Easy है, कर सकते हैं. Very good. Now what happens to the reactivity down the group? This is something you need to pay attention. Chemical reactivity down the group, okay, is different in case of metals and non-metals. Let's say metals की हम बात करते हैं. You know that metals are electropositive. Metals are known for donating the electrons easily. So how do you say a metal is more reactive? If a metal is easily able to lose electrons, it is more reactive. Okay. So chemical reactivity of metals is defined in accordance with their tendency to lose the electrons. If a metal loses electron easily, it is more chemically reactive. And we know left to right जब हम जाते हैं, number of shells are increasing, है ना? Number of shells are continuously increasing. So what happens? The effective nuclear charge decreases. So we know it becomes easier for the metal to lose the electron. किया है ना, टॉप टू बॉटम जाते हो तो मेटालिक कैरेक्टर इंक्रीज करता है. सो दैट मीन्स रिएक्टिविटी ऑफ मेटल्स ऑन गोइंग टॉप टू बॉटम इंक्रीजेस. ठीक है. सो मेटल्स के केस में क्या होता है? व्हेन यू गो टॉप टू बॉटम इन अ ग्रुप द रिएक्टिविटी इंक्रीजेस. व्हाई? बिकॉज द टेंडेंसी ऑफ मेटल्स टू लूज द इलेक्ट्रॉन्स इंक्रीजेस. Okay, now talking about the non-metals, वहाँ थोड़ा सा अलग होगा. Chemical reactivity in non-metals, how it is defined? The tendency to gain the electron. Okay, gain of electron से reactivity will be determined. Now you know that if a non-metal gains the electron easily, it would be more chemically reactive, है ना? And top to bottom आप जा रहे हो, मान लो fluorine, chlorine, bromine, iodine. So what is happening? Number of shells are increasing. Fluorine has 2 shells, chlorine is having 3 shells, bromine will be having 4 shells. So the same trend, effective nuclear charge decreases. So tendency of the element to gain the electron decreases. टॉप टू बॉटम जाते हो, नॉन मेटालिक कैरेक्टर डिक्रीज करता है ना. सो दैट मीन्स रिएक्टिविटी ऑफ नॉन मेटल्स डिक्रीजेस. Okay, so remember this is important trend. Left to right chemical reactivity first decreases, then increases. Top to bottom reactivity, it depends what you are talking about. For metals, top to bottom chemical reactivity increases. For non-metals it decreases. ठीक है, and this question is asked in the exam. You would be given a lot of questions, so you have to do this character. It's very important. Okay, so with this we finally end the periodic trends. One question I would be giving you. You have to tell me how can we determine the group of an element from its इलेक्ट्रॉनिक कॉन्फ़िगरेशन. ठीक है, करके बताना क्लोरीन के लिए. टेल मी पीरियड्स तो मैम ने बता दिया. नंबर ऑफ शेल्स विल टेल यू अबाउट द पीरियड नंबर. हाउ कैन यू डिटरमाइन द ग्रुप नंबर? वो भी इजी है. ग्रुप नंबर के लिए यू नीड टू सी द, देखो, इफ यू वांट टू फाइंड द ग्रुप नंबर यू हैव टू सी द वैलेंस इलेक्ट्रॉन्स. इफ वैलेंस इलेक्ट्रॉन्स आर इक्वल टू 1 or 2, then that will be group number is equal to valence electrons. If valence electrons are like more than 2, then in that case group number is equal to 10 plus valence electrons. ठीक है, एंड बॉन्डिंग वाली चीज़ भी देख लेना. क्वेश्चन आ जाते हैं लाइक यू आर हैविंग ग्रुप नंबर 1, 2 and 13 elements are usually metals. Boron is an exception though. They are metals and they combine with elements of group 15, 16 and 17 which are non-metals to make the ionic bonds. है ना, they make the ionic bonds. Okay, exceptions होते हैं. Now apart from that, if you talk about elements of group 14, 15, 16, 17 and hydrogen, among themselves they make the covalent bonds. Okay, so I hope you remember this. You can, यहाँ पर group 1 में don't take hydrogen. Okay, so the type of bonding and all the trends we are done with this. So I hope this session was helpful for you. One short explanation. Okay, with this we are done with the chapter, and if in case you want to be a part of Vedantu Pro classes, then that is Shilpi Mam's coupon code. You can always apply and get 10% discount. Okay, and make sure that you watch the replay again if in case there was a problem in the session, and from the next time onwards we would be doing a lot of questions. Okay, just do practice and all the best for exam. Bye bye.